All right, this lesson is going to be about common factoring. We're going to start with talking about what common factoring is, and then we are going to look at a few examples. All right, here we go. So common factoring is the opposite of a skill that we've seen before. We've seen something that looks like this, where we are taking something in front of some brackets, and we are trying to apply our distributive property to expand them. So this is what we would call trying to expand. What we are doing now is actually the opposite. So we are trying to go backwards. This is what we call factoring. So when we were expanding something, just to recap a little bit, we applied our distributive property. We multiplied everything in the brackets by this term that was in front of the brackets. So we took 3x, we multiplied it by the x. That's how we got the 3x squared. Then we took the 3x and we multiplied it by the 8. That's where the 24x comes from. So what we are trying to do is sort of undo that. We want to unexpand our brackets. In fact, factoring is actually the opposite of expanding, and basically means we are trying to express something as a product. A product means a multiplication. So here we have a multiplication of 3x times x plus 8. In some more general terms, this is what it might look like if we were trying to expand something. We've got a term in front of brackets. So here we've got a times b plus c. And we multiply the a by the b, and then we multiply the a by the c. And so that's how we ended up with ab plus ac. What we see on the second line is the reverse of that. So we are looking for something to take out of the brackets. And once we have done that, now we have factored it. So this is called factoring. And we've removed it from the brackets. The big problem here is figuring out what we can take out of the brackets. And to do that, we need to look for what we call a greatest common factor. A greatest common factor, we often abbreviate that as GCF, is the greatest factor that divides two numbers. So factor means something that multiplies to a number, and we are looking for something that divides two numbers, or all of the numbers in a term. Let's look at an example. Here are three examples of some expressions, and we're going to look for our greatest common factor, and then we're going to try and factor these. In this first term, in this first expression, we've got 18 r to the 4, and we've got a 12. So a greatest common factor is a number that can be multiplied to give us 18 and 12. So some options of numbers that multiply to both 18 and 12, they're both multiples of the number 3, right? 3 times 4 gives us 12, 3 times 6 gives us 18. Another option is actually 6. 6 times 2 gives us 12, 6 times 3 gives us 18. The G in GCF stands for greatest common factor, so we are looking for the greater of those two numbers, so that's the 6, so not the 3. So that's going to be the number that we pull out of the brackets. So I'm going to have something that looks like this, 6, and then something in brackets. Now, when we were expanding, we were multiplying. So we are doing the opposite. So naturally, that would mean we're dividing something. So we're going to divide 18r to the power 4 by 6. And that means we're just dividing the numbers really here. So that's going to give us 3r to the power 4. And then when we were doing the distributive property, we multiplied every term. So here we're going to divide every term. So the 12 divided by the 6, 12 divided by 6 gives us 2. So we end up with 2. Factoring is super easy to check your answer. So if you think about doing this backwards, if you multiplied 6 times 3r to the power 4, we should get 18r to the power 4. And same with the other term. If we multiply 6 times 2, we get 12. In this other example, there are no numbers, but there is an a squared and an a. So keep in mind, a squared really just means a times a. And then we have an a over here as well. So our greatest common factor in this one actually is just the variable a, because a goes into a squared, right? Because a times a would be a squared, and it obviously goes into a as well. So the thing that we're trying to take out of the brackets will just be the variable a. And just like we did in the first example, we divide them. A squared divided by a gives me a, and negative a divided by a, the a's would cancel out, so I would actually just end up with -1. Sometimes our greatest common factor can have a number and a variable, just like we might see in this third example. So here we have 16x to the power of 3 minus 4x. So our greatest common factor, if we look at the numbers, things that go into both 4 and 16, 2 times 2 is 4, 2 times 8 is 16, or 4. 4 times 1 is 4, 4 times 4 is 16. The greater of those two would be 4. So the number part of our greatest common factor will be 4. And then we're also going to have a variable part of that. We've got an x cubed. We also have an x. So the greatest thing that goes into x and x cubed would be the variable x. A trick there for the variables is that we're really just looking for the lowest exponent of that. So here we had an x to the power of 3. Here we had just x, or x to the power of 1. So that's what we're going to have in our greatest common factor, the lowest of the exponent terms. So the greatest common factor here is 4x. So I'm taking 4x and pulling it out of the brackets. And I'm going to divide these. So the 16 gets divided by the 4, which gives me 4. The x cubed divided by the x gives me x squared. And then this term, 4x divided by 4x, they cancel out. So I end up with 1. Or in this case, since it's negative, -1. Again, if you wanted to check your answers, all you'd have to do is just multiply those. Let's take a look at some trickier ones. Here we have, they're just some longer terms, but really there's nothing too crazy about this. If you're up for a challenge, try pausing the video now and see if you can take a look at these, or maybe even just see if you can come up with the greatest common factor. All right, so in this one, I'm looking for a greatest common factor between these three terms. I'm going to start with the numbers. So I've got a 12, a 24, and a 30. So if I start thinking about numbers that go into 12, 24, and 30, 3, as well as 6. 6 goes into all three of those. 12 goes into 12 and 24, but 12 doesn't go into 30. So our greatest common factor here, number-wise, is going to be 6. This expression has x's and y's, so I'm going to have to look at those separately. If I look at the x's, here I've got x to the 4, here I have x to the 3, and in this term I've got x squared. So the lowest exponent wins, so it'll be x squared. Then I have to also look at the y's. Here I've got a y squared, I have a y squared here. Oh, but I actually don't have a y squared in the last one. So we can't say it's common. It's not a greatest common factor because there is no y in the last term at all. So my greatest common factor will actually just be the 6x squared. Just like the questions on the previous slide, I'm just dividing by that greatest common factor now. So 12 divided by 6 is 2. X to the power of 4 divided by x squared. Right, subtract the exponents, so we've got x squared. And then that y squared, nothing's happening to it, so it's just going to stay in there. And then we can just do this term by term. Move on to the next one here. 24 divided by 6, so we end up with 4. X cubed divided by x squared will be x. Right? Remember, our exponent rule is to just subtract the exponents. So 3 minus 2 gives me 1. And then y squared, that just stays. The 30x squared, 30 divided by 6 will be 5. X squared divided by x squared, those cancel out, so actually just have 5. And there we have it. That one is common factored. I'll take a look at the second one as well. I've got 45, I've got 15, and 60. Those are all multiples of 15. So I'm going to take out 15. I'll look at the a's next. I've got a squared. I've got a, like just a to the power of 1, and same over here. So my greatest common factor will have an a. For b, I just have b on its own here, so I'll have a b as my greatest common factor. And then, again, just divide everything by 15ab. So 45 divided by 15 will be 3. A squared divided by a will give me a. B divided by b, those cancel out. The next term, 15 divided by 15, those cancel out. The a's cancel out. I've got b squared divided by b, so that's just b. The last term, 60 divided by 15 is 4, and the a's and the b's cancel out. So there I have it, 3a minus b minus 4. So again, all we are really doing is we start with finding the greatest common factor. That's where we found the 15ab. And then we just divide every one of the terms. So in each of these there were 3. If there were more, we would divide all of them by that greatest common factor. So here are some steps for common factoring. Our first step is to just look for the greatest common factor of the coefficients and the constant term. By constant term, we mean if there's a term that just has a number, no variables in it. 3 would be a constant term, for instance. And then we also look for a greatest common factor of the variables. So if is there an x squared and there's an x cubed and an x to the 4, we would look for the lowest of those 3. Once we do that, then we take our greatest common factor, we put it outside of the brackets, and then we divide everything to fill in the brackets. I've got one more tricky example to try here. In this example, we can see that we have this w plus 1 in all of the terms. I just want to use this example to point out that a greatest common factor doesn't have to just be one term on its own. So in this example, we can see that every term is multiplied by w plus 1. We can actually just common factor out a w plus 1, just like we common factored out any of the other numbers or variables in any of the other questions. So what would that look like? Well, my greatest common factor is just w plus 1. There's nothing else that's common here. We've got an x, a y, and no variables. And 4, 5, and 3 don't have anything in common. So I'll just take out the w plus 1. And then in brackets, divide all of these by w plus 1. So really that just means the w plus 1's cancel out. So we end up with 4x, we end up with 5y, and we have minus 3. So there we have it. That is common factoring. We will be back in another video lesson with some other types of factoring tomorrow. Good luck.